Hi everyone, I hope and trust that you're well. This is Ndogozo, your math and physical science tutor. So yeah, today we are back again with grade 12 physical sciences. So we're just going to be doing this some of the concept of momentum, understanding what momentum is, and also getting into impulse. And for this topic, guys, or in fact for most topics in physics, like it's best to actually or firstly understand the definitions before going into application, because application is just integrated from a definition. So if you understand the definitions, and then it's going to be simple to actually apply those terms in solving the problems. So yes, welcome to our presentation in grade 12 momentum and impulse. So in these sessions, we're just going to be exploring more on momentum and impulse. So I think this is the first topic for most of the physical sciences textbook that you will be using, or you are using at your schools. So firstly, what is momentum? So we'll be talking more regarding momentum. So what is momentum? So definition of momentum is basically defined to be the product of mass and velocity. So momentum is basically defined as the product of mass and velocity. And guys, take note that the word product simply means you are going to be multiplying. So the word product simply means that you multiply. So mathematically, product simply means you multiply. If you want the product of something, that means you're going to be multiply those two things. So for momentum, as it is saying that it is a product of an object's mass and velocity, meaning that you'll be taking the mass then multiplying with the velocity. That's what momentum is. You're just going to be taking the mass, multiplying it with the velocity. And then even if we go and take a look at the definitions, at the equation, I mean, so you can see that momentum, which is denoted as p or represented as a small p, it is then equal to the mass, which is denoted as small m, multiplied by the velocity, which is denoted as small v. So this equation here supports the definition that we just spoke about. Definition said that the momentum is the product. It is just taking your mass, multiplying it with velocity. And as we are seeing here, the equation definitely supports that. The equation definitely supports that. The equation, what does the equation says? The equation says you're just going to be taking the p, which stands for the momentum, and then equal to the mass, which is small m, taking it or multiplying it with what? With your small velocity. Forgive me, guys, for writing this ugly, because I'm using a cursor. I'm using the actual mouse. Yes. So momentum is you're just going to be taking your mass, then multiplying with the velocity. That then you will be getting what is called a momentum. And then the SI unit. So one thing you're supposed to be always to take into account are the SI units. The SI unit for a mass in most cases is what is in kilograms. Mass is in kilograms, and then a velocity is in meters per second. So per second simply means it's going to be meter divided by second. Okay, and then or someone else might write it in this way: m dot s, which stands for second to the power of -1. So someone else might write it in this way, someone else might write it in this way. So it's still the same thing. These are the same thing. Okay, and then the momentum here, it is just going to be the unit for SI unit for momentum is going to be the combination of the unit of mass, and then with the combination of the unit of what? Of velocity. Since it's kilogram, and then it's going to be meters there. Why? Because of this kilogram multiplied by that meter there. Taking the numerator, multiplying them together, you get kilogram times meter. And then because you can see that the s, which is at the denominator, it is just going to be still s here. Why? Because of just going to be that s multiplying by the denominator here, which is 1. Hence why you're just going to, it is going to be s at the bottom. And then from afterwards, we're going to be learning about the conservation. The word conservation means that something remains the same. So the conservation of momentum, you're supposed to know this definition, guys. So firstly, the keynote that you're supposed to take out is that you need to know the definition of what a momentum is, and then you need to know what is the definition of the conservation of momentum. Those two questions, they are exempted. So they can ask you in an exam what is a momentum or what is a conservation of momentum. So those two definitions, they are very essential. So the definition of a conservation of momentum is the total momentum of a system remains constant. So why is remains constant? Because there's a word conservation there. The word conservation means does not change. It means that it remains constant. So a conservation of momentum, this is the total momentum of a system that does not change if no external force acts on it. So that is the entire definition of the conservation of momentum. So it simply says that the momentum or the total momentum will never change whenever there is no other forces that are acting or influencing that particular system. So that's what conservation of momentum simply entails. So this principle is known as the conservation of momentum. What conservation of momentum? Remember, it is the total momentum of a system remaining constant, provided that there is no external forces acting. And then moving quickly to an impulse. What is an impulse? Impulse is defined as a change in momentum experienced by an object when a force is applied to it for a certain period of time. So guys, take note of this also, that this definition might not be exactly the same words as that one of the textbook you are using or will be using, but there are keynotes that you're supposed to be always pointing out whenever you're giving definition of these terms. So the keynote is the keynote are: impulse is the change in momentum. So the word change in momentum, you are supposed to always point it out whenever you're writing the definition of the impulse, because of that is the keynote, that a momentum is the change in impulse. So it is experienced by an object when a force is applied. Force is applied to it for a certain period of time. So those are the key words for the definition of an impulse. So also, as you can see here, the equation supports what the definition entails, because of we said that the equation always follows what the definition says. So as you can see here, it says the impulse is the change in momentum, and as you can see here, this is the equation of an impulse, denoted by capital letter J, equal to what? Equal to the change in momentum experienced by an object when a force is applied. So you can see that here it is talking about the force applied, and also from the equation there is a force applied, and then here they're saying to it for a certain period of time, and they are mentioning time there. And also from the equation you have what is you have the scalar, or the quantity of time. So you can see that the definition really does support what the definition supports the equation, or the equation supports what the equation entails. Okay, and then here they're telling us about the relationship between the momentum and the impulse. The relationship between the momentum and an impulse is that one that the impulse applied to an object is equal to the change in momentum it undergoes. So that is the relationship. Relationship is that the impulse is equal to the change in momentum. That is the summary of the main relationship. That the impulse, which is denoted as J, capital letter J, is equal to what? Is equal to the change in momentum it undergoes. So this here, guys, is what or shows us the